it becomes too bothersome, we'll close it. But you know, if we can put up with it, we put up with it. If not, not. So one of the problems, right, and it applies to the characteristic, but in general, is that we have to study objects that change with time. They change in their form, in their interaction, in the rules of the game, at least at the superficial level, right? Quantities change. In particular, that's why I think this is important. It's the whole drama of social scientists using statistics. All the statistical tools we have, but a few, are elaborated under the hypothesis of time stationarity. The whole theory of probability has to do, you know, whatever foundation you want to use, with tossing a coin, right? Or with random white noise movement, okay? And those things are time invariant. It's always the same. There is an underlying probability distribution. You keep tossing, you know, right? And this is something that has created a gigantic set of tools, statistical tools. Now, sure, there are tools that try to handle non-stationarity. Economists have contributed some. But if you think of it, they're really small tricks. Think of the whole idea of co-integration. It's not a big deal. It doesn't really change the statistical logic you use, right? So that makes our problem very difficult because, for example, all macroeconomic variables are non-stationary. And so we do all these strange things that, if you are not careful, don't make sense, of the trending, taking first differences, you know, in order to do what? To create variables that we can consider stationary random variable, and Kolmogorov stationarity theorem applies. Yeah, but it's not obvious that by doing so we make sense. Let's better be aware of this. That's why I have a, you know, often very hysterical reaction, in the sense that it makes me laugh, on people taking some kind of sophisticated econometrics when applied to especially macroeconomic data too seriously. I'm much more in favor of looking at simple data, simple graphs, simple statistics, and I know what I'm doing, than using atomic bombs to try to create stationary processes that satisfy such and such a theorem out of macro data that are measured as they measure, are changing over time, even the definition which they're measured, the unit of measurement. We're now measuring the same experiment in the same lab over time with the same instrument, and moreover are known time stationary. Okay, it's completely unclear to me, instance by instance, what the hell we are actually testing. Okay, so this is true also for development theory, right? And think about, you know, consumption. All measure of consumption, you know, is non-stationary, and the panel of things on which we look at the basket changes continuously over time. Right? I think we already mentioned the fact that, for example, the observation that consumption per capita, in the way we measure it, has increased so much over time that trying to handle that with a standard utility function, which happiness depends on the absolute level of consumption, will lead you to the conclusion that, if, you know, with the exception of the last 100 years, humanity has lived in desperation for thousands of years, and that seems to be definitely not the case, right? We discussed this in habit forming. So the characteristic thing wants to try, it's a way of trying to attenuate that, and it offers you what? Time invariant utility, right? You define on a set of characteristic C, and mapping into the real line. C is a small subset of Rn, right, with n not so big. Now this is all empirical, but the point is not so big. I mean, we easily can measure goods by the millions, whereas probably we can try to define human happiness around a few thousands at most characteristics. Now you say, well, a few thousands is a lot. Yes, but it's a lot less than a million or a billion, okay? It's at least potentially measurable by neuroscience type of instruments and approaches, and in fact, people have started to do that. Actually, some Italian colleagues are at the forefront of this. And so it's a lot more manageable than the thing, and in particular. So the idea is that given that, you know, each good, let's call it I, you consume good I in any quantity, but let's look at good I consuming at the unit value. 1 unit of shoes, 1 unit of t-shirt is a vector of characteristic. Characteristic 1 to characteristic n of good I. And I is it's a number that can become infinity because we can have an infinity of goods, okay? Okay? This is a vector of numbers. Most of them are 0 because goods satisfy only a small subset of characteristics each good, okay? This allows you to have a process of innovation that you can model as you feel, completely independent. We will see a couple of ways of modeling the process of innovation, but that's just, you know, your theory of innovation. But given the good, you can map it into utility by doing that. So if you're consuming at time t a vector xt, we have vector xt as good x1 period t, x2 at period t, x, call it, not to use m all the time, m in period t, right? Then what's the utility you receive from that? Well, you take good at 1 and you take its vector of characteristics, right? So I consume x1 t unit of characteristic c11, right? Those are two. Now let me use, that's just a scalar, right? You remember, this is a quantity, 7 kilos, 3 shirts, 5 liters, plus quantity x2t of characteristic 1, 2. That's the characteristic 1 in good 2. And so on. I add it up until I get to good m, characteristic 1 in good m, right? What is that? That's a scalar number that measures the total amount of characteristic 1 I'm consuming at time t, right? If you notice, right, it's the inner product between the, well, depends how I stack them, right? The vector xt and the first entry of the column of characteristic of each good, or the row vector if you want, right? The row vector of the matrix characteristic by goods, okay? You do that for each characteristic, right? So the last one is going to be x1t c1n plus x2t c2n all the way to xmt cnm equal characteristic n in period t. And I have a whole vector. Utility is defined over that. So, if we treat x as a row vector, okay, we can write that in matrix form as xt, row vector. It has m entries, so multiply a matrix C. The matrix C is as what? As m by infinity, right? As m rows and infinite number of columns. Why an infinite number of columns? Because the goods are potentially an infinite number. Wait. What have I done wrong? I just did it wrong. What an idiot. My stupid. Look at that. I just wrote it wrong. I always do it with matrices. It's my characteristic. It's wrong, right?
M is the vector.
No! So M is the vector at time t, but because the vector of goods is infinite dimension, this is a vector This was not intentional. Some of the errors in the past were intentional to see if you were alert. This one is a real oversight. Good that I noticed it. So a vector is like that, and then there are zeros. Right? An infinite number of zeros, the good that we're not yet producing. Right? Right? So the vector is always infinite dimensional. All potential goods that we can ever produce. It's got a bunch of positive entries, which are the goods we're producing right now. It doesn't contain the good that we used to produce, but we're no longer producing, and the goods that we will produce, but we're not yet producing. Okay? So in fact, maybe there are zeros also here, right? If we put them in temporal order, the old axe of the Romans is here, and it's got a zero. We're not producing it anymore. Okay? So first of all, that vector is infinite dimensional, and the matrix, we use the matrix, either pre or post, doesn't matter, to map the vector, which is infinite dimensional, into what? Into the characteristic. The characteristic at dimension n. So that the matrix C maps a space that is infinite dimensional into a space that is finite dimensional. Also, Baudry, you idiot. C is infinite times n. Right? There's an infinite number of rows, right? One per good, and n columns, one per characteristics. Right? If you prefer to write it as C prime x prime, then it is n times infinity, and it maps into n times infinity that picks up, that's more, I think, intuitive, right? N times infinity picks up an infinite dimensional vector and puts it into n, right? Okay. Okay, is that clear? What is that we pointed out about this method? Well, it's very simple, at least analytically it's very simple, very elegant. Obviously, in science or in research or in theorizing, like in everything, there's never a free lunch. Nothing comes for free. So this is simple and easy, but it has a drawback. A drawback that actually people using hedonic price and people doing marketing seriously have been considering. It's called bundling. And there is a literature also in applied microeconomics about bundling recently. Right? Think about bundling. Bundling is perfectly representable by this. This is the success of this is the proof how valuable bundling is. Right? What's bundling? Bundling is to put many things in a bundle together. All right? The success of this is that this has become an infinite number of things. Right? A calendar, a phone, a camera, a PC, a video camera, a dating tool, a storage thing. You know, I don't know many things are in there. You know, I just look at my apps, you know, and there is everything. There is the shopping, the calendar, the bussola, the Dropbox, the photo camera, the mail, the healthcare account, the thing that tracks my exercise, the watch, the music, blah, 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 right? This is bundling. Yeah, I can take this and break it down in the value of its characteristic and add them linearly. I'm not going to get to the value of this, right? The value of those things is multiplied probably by a big factor by the fact that they come all together and in such a small space, right? That makes it even more valuable. Yes, each one of those things has value. It's useful to have a calendar, it's useful to take pictures, it's useful to have a record, it's used to have your readings around when you have a moment to study, whatever. But having them all together, interchangeable and they can communicate, is of a much bigger value. Right? That's bundling. What that implies is this mapping is clearly a very crude approximation to utility. Right? If I use this to evaluate the utility of a cell phone, the utility of the utility of a car, right? A car is an example of bundling. You can do many things with cars, right? Young people know exactly that it can be a good substitute for a bedroom, right? It's called bundling there too, bundling and other stuff. Okay? Now you look, right? You got to use these things to think of what's going on. So this is an approximation. Now, obviously, so it's a costly thing in the sense that we give up value. And if you have to use this to do serious marketing, you get much more sophisticated. You avoid the linear. Now, from the point of view of the general abstract theory, it has a big advantage which I mentioned the other day. So let's say it again. It has the fact that it allows you to think at new goods as new ways of spanning the space of characteristics. Use a bit of linear algebra, right? At the end, the space of characteristics we want to satisfy is a finite dimensional space. Use the best example I can do. I'm not good at drawing, so I'll try to draw a three-dimensional plane, right? Right? Characteristic 1, characteristic 2, characteristic 3. And my utility lives somewhere here. Right? The point of new goods is that they introduce new way of spanning the point. Like I can have elementary good, right? This is 0 every, this is 0, 0, 1. This is 0, 1, 0. And this is, 1, 0, 0, right? That's a good. Oh, actually, sorry, that's 3 goods that defines it. But I can introduce a good that alone, and that's innovation, can do all 3. Maybe with coordinate alpha, beta, gamma. They don't need to be 1. Right? What will be the price of that good? The good x4, right? This is the good x3, this is the good x1, and this is the good x2. And they exist already. This has price P1, sorry, P3, P1, and P2. These are very simple goods. They're kind of basis of the characteristic space, so their price are actually the price of the characteristic. In general, probably those who don't exist, we're just using them in class, right? But in general, what you do, you look at actual goods that are bundles of characteristics or mixture of characteristics, you look at what they're priced, you invert the matrix, right? And you run a regression basically, or you do a linear projection trying to extract from the data the way people price certain characteristics, right? That's what you do in marketing, right? Here we do the reverse, right? Well, what's the price of this good? If the pricing is linear, its upper price is alpha plus beta plus gamma, right? That's the upper bound on its price. If it costs more than alpha plus beta plus gamma, it's not convenient to produce that good because people can do better by buying the 3 goods. As you notice, if bundling has utility effect, then the price of the good can go above alpha plus beta plus gamma. You can try to think about transaction cost, right? That's one way of thinking about bundling. Bundling reduces transaction cost. The transaction cost of the individual of moving, or call them adjustment costs. If you know, transaction is often used in economics to indicate, interpersonal bargaining of moving or having to agree on something. You can call them adjustment with yourself. You gotta move from, put down the calendar, pick up the camera, put down the camera, and then pick up the, the book, all right? Okay, so if that has value, then obviously the price can be larger than alpha plus beta plus gamma because you reduce those adjustment costs. That's it, I stop here. That's the theory. That's the very, 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 very basic. If you want to study, there is literature there. I have some notes, never published anything, but I've been thinking about this for a while. I find it as a useful way of thinking about it. I believe it should be used, it would be very useful for people doing what's called structural change, because it would be a very different way of thinking at structural change. People think a structural change is moving from agriculture to manufacturing and industry to services. I think structural change is simply different technological ways of satisfying the same characteristic. And the process through which I travel through the space of good is dictated by the need to satisfy characteristic and the technological possibilities that make it economically feasible. Okay, so that's the summary of where we were last week. And so now let's think a moment. So do you have questions, guys, about the agion over, or should we try to look a bit at the way this Schumpeterian argument works? Okay, so the Schumpeterian, I hate to call it Schumpeterian because really it's only a part of Schumpeter, in my opinion, not the most interesting, but it's become fashionable to call it that way, so we will be forced to call it that way. So what's the basic intuition that we write a bit? Did you look at the equations a bit? No, I can see from your eyes that you haven't. Huh?
Your paper?
No,